Good evening, hi. We are from Group C1 and we are here to present to you the long report presentation in a title with Filtration in Water Treatment Industry. First of all, I would like to introduce you, our group member. Roger Zeng, Kuda Singh, Gogasin, and Noh Hanisa binti Muhammad Zambri. Next is our flow of the presentation. First of all, we will present to you introduction and customer requirement, and my colleague will present to you the process description, unit and equipment description, result analysis, economic analysis, safety and other consideration, and last but not least, the conclusion. So, what is water treatment industry? Water treatment industry is one of the important industry in our daily life. It acquires clean, neutralized, and sterilized water for our daily activities. Water treatment industry basically convert raw water into purified water through several separation processes. It involves two kinds of process, which is physical process and chemical process. The physical process involved is sedimentation, filtration, screening, and settling. This physical process is used to remove the solid particles which are unwanted in every water supply. The chemical process involves disinfection and coagulation. The chemical process is used to remove the unwanted toxicants and chemicals in the water. Water filtration is a process to separating the suspended or colloidal impurities from the water by passing through a porous medium, usually a bed of backup sand or other medium. When the water fills the pores or the open space between the sand particles, the impurities are left behind, either coiled in the open space or attached to the sand itself. So, this is the objective of our experiments. First, to study the filterability characteristic of a given suspension performance of a standard water in quality test. To determine the specific filter cake resistance and filter medium resistance in order to determine the filterability index. To verify the basic principle of filter operation for student study, and last but not least, to study the effect of different diameter size of the sand as the filter on the flow rate of the filter. The next part of the presentation is customer requirement. Treated water has different use in different countries. Residents in Newington, Sydney, Australia use the treated water in their daily activities like washing the car, watering the garden, and toilet flushing. In Singapore, treated water gets used for electronic chips manufacturing that demand high quality water than the drinking water. Next is the market demand for the water treatment equipment. It expected to grow 5.9% per year to $13 billion in year 2017. It's because the rise of the concern for the society toward the health risks and environmental impact of biological contaminants, chemicals, and diffusion byproducts in both supply water and wastewater. The second reason is the treatment requirement for produced water in oil and natural gas extraction continue to rise, and as water recycling and reuse increase to satisfy the need of expanded hydraulic fracturing activities, and the need for very high quality processed water in a number of applications to support greater demand for the technologies. That's all for my part of my presentation. The next part of presentation will be presented by my colleague Kuda Singh, and I would like to pass the floor to him.
Hi, so now I would like to present to you the process description of water treatment industry. The first process is screening. Screening is very important because it functions to remove large particles and allow the rest of the water to pass through it. Secondly is the process pre-chlorination. In this stage, chlorine is added in rapid mixing chamber in order to remove algae and other biological organisms. Next. After that, flash mixing follow. In this stage, water is mixed and stirred quickly for a minute or sometimes less than a minute in order to distribute chemical evenly through the water. After that, coagulation follows. In this stage, coagulating agents is added in order to neutralize the electrical charge of fine particles in the water in order to keep particles apart. Flocculation follows after coagulation step. During flocculations, gentle mixing of the water for a period of time between 30 to 45 minutes in order to bring the tiny flow particles and small dirt particles together to form large particles, which call it as flow. So after that, sedimentation. Sedimentation is an important step. It functions to allow the heavy flow particles to settle to the bottom of the sink by gravity. So now is the filtration. Filtration functions to allow water pass through silica sand and purpose, which function as a porous medium. As the sand filters begin to clog up because of the trapped particles, backwashing is needed as a form of maintenance so that the filter media can be reused. The last stage for water treatment industry is disinfection. Disinfection is to kill microorganisms, bacteria and viruses that may be present in the water. So normally in this stage, we will use chlorine dioxide or chloroamines as disinfection agents. Next, I would like to present to you the process unit or equipment of our experiment. As you can see from the slide, we call this equipment as filtration index unit. It consists of bench, differential pressure meter, needle swab, filter unit and flow meter. So basically, this equipment uses the separation process, which is mechanical filtration. Filtration is the process of separating suspended solid matter from a liquid by causing the latter to pass through the pores of some substance called a filter. So now I would like to present to you the capability of this equipment. The first capability of this equipment is to measure the filterability of a given suspension of a standard water quality test. Besides, it allows students to perform water quality tests through a standard procedure for filtration. Lastly, it demonstrates the principle of filtration for student study. So the operating description for this equipment is very simple. Basically, users allow the water to flow through a sand or porous media. Normally, we will use deep bed of porous granular media for this experiment. So as you can see from the previous diagram, it consists of a feeding tanks where initial solution of water with solid suspension is placed. The tanks is communicated with the sand filter, which is the porous media, and the porous media will function to trap the solid suspension. So the filter lower part is communicated with the flow meter. The flow meter is used to measure the flow of the water that pass through the porous media. Lastly, a regulation board is needed and is located after the flow meter in order for students to measure the flow of water. Thank you. Next, I would like to pass the floor to Kokashing to present the next part of our presentation.
Okay, so now I would like to present the result analysis from our experiment. So this tree table is the raw data we got from our experiment, which is from the computer software from the filterability index unit. So from this tree data, we are able to plot the flow rate against the time. Okay, so this is the graph of the flow rate versus the time. We compare the flow rate of the three experiments with different sizes of sand particles with the time and the flow rate. As you can see from the graph, the flow rate decreased slightly with time in the initial, but at the end drops towards the zero because the volume is going to finish. Okay, from the data we obtained just now, we are able to calculate the volume V and the ratio T over V. And then we plot a graph of T over V against the volume. So the three experiment, this is the three graph we get from our three experiment. Experiment is for the 500 micrometer sand. Experiment 2 is for 700 micrometer sand particle. And experiment 3 is for 100,000 micrometer sand particle. Then from the graph, we can see that the trend is almost similar, which shows that the ratio T over V increase when the volume increase. Then we also can linearize this graph so we can get the linear equation, which is y equals to mx plus c. Okay. After that, from the graph of T over V against V, we can calculate the Kp by comparing equation 1 with the graph linear equation y equals to mx plus c. So as you can see from the equation 1, T over V is the y, Kp over 2 is the slope of the graph, which is the m, and then V is the intercept of the graph. Then after that, from equation 2, we can calculate the specific filter cake resistance, which is the alpha. Then after that, we also can calculate the filter medium resistance, Rm, from the intercept, which is the V, as you can see from the equation 3. After we calculate the result, we are able to get the specific filter cake resistance alpha and the filter medium resistance from this table. As you can see from this table, when the size of particle of the filter increase, the specific filter cake resistance decrease, and also the filter medium resistance decrease. This concludes that when the size of the particle of the filter increase, the flow will be faster as the resistance is smaller. Okay, after the result analysis, I would like to brief you about the economic analysis of this water treatment plant. A typical water treatment plant is very difficult to estimate the cost because we have to consider these three main factors, which is water right cost, that different from place to place, and also initial construction cost, which cost differently according to facility size, labor, and the housing area. Then after that, we also have to consider the continued operating and maintenance cost, which consists of the chemical cost, the gallons produced per year, and also the capital replacement of the unit. Okay, next. Okay, in order to study the economic analysis, we refer to a case study done by Kelly, Sue, Roger on the McAllen Northwest facility. This McAllen Northwest facility has a maximum capacity of 8.25 million gallons per day. But the plant, due to limiting factor, the plants only operate at 78% of the maximum capacity, which is only 6.44 million gallons per day. So, from this case study, we are able to get the baseline result, which is $771.67 per acre feet per year times the factor of 2.37 per 1,000 gallon per year produced. Okay, so from this table, we are able to analyze the initial construction cost for the McAllen Northwest facility. So the total initial construction cost from this table is almost 23 million USD dollar. Okay, next is the capital replacement item cost for the McAllen Northwest facility. From the table, we can see that each item costs differently for the McAllen Northwest facility. Okay, that's all about the economic analysis, and I would like to pass the floor to Ms. Anissa to continue the presentation.
Hi, next I will present about safety and other consideration. Water treatment plant offers many occupational hazards. So in order to protect the workers and the visitor, there are many safety precautions that can be done. For example, is handlers and guards around tanks, trenches, pits, towers, and other hazardous structures. The plant also should have appropriate place warning sign, proper lighting and treatment facilities, and the worker should wear protective clothing and equipment such as goggles, boots, and gloves. So there are several chemicals that will involve in water treatment plant, such as disinfectant, which is used to kill microorganisms, oxidant, resin cleaner, and neutralizing agent, which is to control the pH of the water. Next. There are several rules for chemical handling and safety. There are hazard communication, process safety management of highly hazardous chemicals, risk management plan, emergency planning, and community right to know act. So the first one is hazard communication. Hazard communication, also known as the right to know law. All employees in the water treatment plant must be informed of the chemicals that they they are exposed to. The rule requires keeping material safety data sheet for every chemicals and providing employee training on how to safely handle the chemicals and take protective measures. The second rule is the process safety management of highly hazardous chemicals. This rule targets highly hazardous chemicals that could cause catastrophic events which can cause the death of the worker. One of the important elements is the process hazard analysis (PHA). The need for process safety management is based on the amount of the certain highly hazardous chemicals stored or used on site. The third rule is the risk management plan. The risk management plan is the rule to protect the public and the environment from the release of highly hazardous chemicals. The risk management plan is a US EPA regulation regarding facilities that produce, use or store highly hazardous chemicals to develop a RMP, which documents the treatment plan's risk management program and submit it to the EPA. The last rule is the emergency planning and community right to know act. This rule requires planning and reporting on hazardous and toxic chemical. Treatment plants must submit MSTS and chemical inventory to state and local emergency planning official and to the local fire department. A toxic release inventory form must be complete and submitted each year. And then this is the last part of our presentation, which is conclusion. For the experiment, the conclusion is the bigger the size of the porous medium, the lower the specificate and filter medium resistance, less time is consumed for the filtration process. And for the water treatment facilities, the filtration is one of the most important steps in the water treatment industry by removing the unwanted particles to obtain the more purified water. That's all from our group. Thank you.